All right, so let's go ahead and go through the bell ringer. There's a little trick to how to do this and figure out what's what. So we're going to go through that as we review today. But right now I'm just going to go through the answers. Okay, and then we'll go through an easy way to help you identify these. So number 1 should be synthesis. 2 is decomposition. 3 is single replacement. 4 is synthesis. 5 decomposition. 6 single replacement. 7 is synthesis. 8 is double replacement. 9 is decomposition. And 10 is double replacement. I'm double checking that none of those were combustion or, no, they weren't. All right, so that is that. Yeah, question. It is not, because water is not a product. It has to have both water and CO2. That's a great question. Okay. So for something to be combustion, it always has to have water and CO2 both as your product. And we'll go through that here as we review it. Any other questions on the bell ring? All right. You guys did a really good job on your labs yesterday. I handed those back. You can do corrections on lab number 9. So you'll have some time today to get with your lab partners and go through if you need to correct anything for that. All right, so let's go through and review a little bit here. We're going to start with the law of conservation of mass. Again, we've talked about this several times this year. Your quiz on Monday is going to ask you some questions about the law of conservation of mass. So make sure you know what it is, what the definition is. The mass you start with has to be the mass that you end with, or mass can't be created or destroyed. And one of the questions in your lab asked, how does a balanced equation show that? And most of you did a great job talking about how your reactants and your products have to be the same masses, okay? So how do we show that? That's the thing that you guys have to understand. How do we show that the mass is the same in the reactants that we start with, right? These are the reactants. And in the products. How do we show that those are both the same? What do we have to look at? Okay.
Like the number of each element.
Right, we look at each element separately and how many we have of each. So if we would look here, we can see we've got, right, 2 NAs here and we've got 2 NAs here. So that's the same on each side. We've got a CO3 here and we've got a CO3 here. Same thing. We've got a CA here and a CA here. And we've got 2 CLs here and we've got 2 CLs here. Okay. So we have the same number of each atom on each side. So if we weighed those out, right, they would have the exact same mass because we have the same number of each. So if we look at the second, this is the equation that you did yesterday in your lab. Okay, this is the second reaction that you did in your lab. This one's a little more difficult because if we look here, we've got a CO3 on this side and an SO4 here. We've got an SO4 here, but we don't have a CO3 over here. But we do have a CO2 and an extra oxygen here that would make up this. Does everybody see that okay? Then we have our 2 hydrogen here. 2 hydrogen here. We have a CA here. And we have a CA. Okay. So that's basically all you have to do is look and make sure there's the same number. So that's going to be part of your quiz on Monday, is explaining that. So any questions on that at all? Again, I know we've done it several times, so I don't want to bore you, but I want to make sure that we go back through that and remember that. The other thing that's going to be on your quiz is writing formulas. Okay, so I want you to just get out a scrap piece of paper, your notes, and I want you to write the formulas for these 3 substances. Iron 2 and oxygen going together, potassium and chlorine or chloride going together. I should write chlorine here instead of chloride. So potassium and chlorine, and then barium and hydroxide. So get out your periodic tables, polyatomic ion sheets, and write out those formulas. We're going to have, I think there's just 3 formulas on your quiz for Monday. Number 2, that the review sites for writing formulas were posted on block day. If you need to go back and review those this weekend, those are there for you to use. All right, so what are the important things we have to know to be able to write these formulas correctly? Aiden? Charges. Okay, so we have to have the symbols and the charges. So iron 2 means that the charge on iron is going to be what? 2. Okay, so we know iron is Fe plus 2. Oxygen always has a charge of minus 2. It's in group 16. Okay. So when we write that formula, we only need one of each because the 2's are going to cancel out. So you should have had FeO. I picked easy ones, didn't I? Potassium, group 1, so it's a +1. Chlorine, group 17, so it's a -1. So again, charges cancel. CO. Last one, barium is in group 2. So +2. Hydroxide, it does end in IDE, but where do we find hydroxide? Not on the periodic table. Where is it? Polyatomic ion sheet. This is OH. That's a -1 charge. So this one you do need 2 OHs to cancel out that Ba. Has to be in parentheses. Don't forget to put the hydroxide in parentheses. We do not have just 2 H's, we have 2 OHs. So those are the types of formulas you're going to see in this course. Do we want to do a couple more or we feel comfortable with it? Should we good? Okay. Again, review, but it's easy to forget those things when we haven't done them in a while. All right, so those are the things that are going to be on your quiz on Monday. We're not going to have any balancing of equations yet. We'll get to that next week after we practice a little bit. All right, so let's go back and review those different types of chemical reactions. You might want to get out your notes because you can add some things in your notes as we go through this and review it. Now, there's 6 different types of reactions. When you break them down and look for just one type, it makes it a lot easier than if you go through and you're trying to look at everything at one time. So my suggestion is when you're going through a worksheet and you're trying to identify, just pick one type, go through and find all of those. Then go to the next type, go through and find all of those. It makes it a little bit easier. So for synthesis, what you're always going to see, generically, it's going to be AB, A plus B always goes to AB. So basically, you're taking 2 things, you're combining it into one, and we end up with usually just one product. And we've done that. We did that in a previous chapter where we talked about that. So synthesis is usually one of the easiest ones to identify. Taking 2 things, combining them into one. Decomposition then is the opposite. We have 2 things together. They're going to break up into 2 separate things. Okay, so again, usually that's fairly simple to identify because you're starting with just one compound and then you end up with 2 products. Then we get into the ones that are a little more confusing. Double replacement. Okay, so when we look at double replacement, the generic equation we usually give you is this. But then it's like, okay, well, what does that mean? So if we translate this into chemistry words, these are all compounds. Every single one of them, because we have more than one element combined together. So when you're looking, get out your worksheet that I handed back today and find a double replacement reaction. When you're looking at that double replacement reaction, or use your entrance book, either one. Notice how you have a compound. And you have another compound. And then in your products, you have 2 compounds. Okay, it's always going to be that way. So one from your homework, you have PbCl2, and we're adding to that Li2SO4, both compounds. Okay, then what happens is the lead here switches spots and goes with the SO4. So we end up with PbSO4. So the lead changes and goes to this spot. The lithium changes and goes to this spot. So we end up with LiCl. So it's all compounds, and that metal that's in this compound switches spots with the metal that is in this compound, and we get 2 different compounds in the end. but it's all compounds all the way across. Single replacement, on the other hand, is an element plus a compound. Then you get an element and a new compound. So if you find a single replacement reaction on your entrance slip or your homework, you will see that in the reactants, you have one single element that's by itself. Then you have a compound. And in the products, it's the same way. So the one that's in your homework, you have Al plus Fe2O3. Element all by itself, compound. Then the aluminum and the iron switch spots. Iron is then by itself as an element, and aluminum goes with oxygen, and you get a new compound. But see the difference? Element and element. Where when you have your double, it's compound, 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 compound. So that helps you identify that. Okay. A single replacement always has that. The metals are still switching spots with each other, these two, but one's by itself. And we'll work with these each individually so you'll get more confident with them. Combustion is something burning. Okay, so you're going to have something with C and H in it. You're going to have oxygen, right? Because for something to burn, you have to have oxygen. Most of the fuels that we have are carbon and hydrogen in some combination, okay? Methane's the simplest one, so that's usually the one I pick. And your two products, like we just mentioned a little bit ago, have to be water and carbon dioxide, and those are the only products you will have in a combustion reaction. So as you're looking through all your examples, pick out all your combustion reactions by just looking at the products. If they only have those two things as products, most likely it's a combustion reaction. If you look into your reactants, always make sure there's oxygen here. And that has to be a combustion reaction. So again, kind of break it down so you're looking at one thing at a time and not trying to look at all the reactions and figure out each one separately. It makes it confusing that way. Okay. So combustion are usually pretty easy to pick out when you look for those things. All right, then the last one, neutralization. I don't believe I covered this one in your notes at all. This one's a little tricky. But what a neutralization reaction is an acid and a base. When you combine those together, we end up with what we call a salt. And a salt is just a positive and a negative ion combined together, and water. So if you have a reaction that has water as a product, but not carbon dioxide, because if it's water and carbon dioxide both, we know it's combustion. If it's water and something else, there's a good chance that it's a neutralization reaction. But the way you can double check is when you have an acid is always going to start with a hydrogen and have something after it. So it could be HCl, it could be H2SO4, it could be HBr, it could be H3PO3 or PO4, excuse me. Okay, they all start with a hydrogen or more than one hydrogen. So those are going to be your acids. Your bases then are always going to end in OH. So you might have NaOH. You might have BaOH2. You might have KOH. Okay, there's lots. There's strontium hydroxide. There's a whole ton of them. But they all end in OH. So you're going to have something that starts with an H, something that ends in an OH. Well, that's where the water comes from. Okay. And then whatever's left, so let's say it's hydrochloric acid and it's NaOH. Okay. The OH here and the H here make water, then this and this combine to make your salt, that positive and negative ion. So that's where neutralization reactions come into play. They are also double replacement reactions. But as right now, I want you to identify them as neutralization because of the acid and the base in the water. Right, questions from you guys on any of that? Hopefully that kind of clarified a few things. So what I would like you to do right now is do any corrections on your homework that I handed out today. Get with your lab partners and do any corrections on your lab 9 if you need to do that, okay? If you got a 10 out of 10, just let your lab partner know that and you're good to go. And then I want you guys to either go back to the practice websites and practice your formulas if you need to, or your balancing, okay? If you need that, those are on yesterday's. And then you have 2 videos to watch for homework and a worksheet to complete. You can work on any of that for the last 20 minutes. If you have questions, just ask.